Hello everyone. Today we're going to be looking at surge. If you don't know what surge is basically it refers to an increase in the pricing of rides during periods of high demand. So when there is a lot of demand, when there is a lot of people making requests for a ride, there is the price increases. So when the demand for rides exceed the number of available drivers in a particular area, the ride-hailing app may implement surge pricing to incentivize more drivers to become available and balance the supply and demand. So basically, the reason why they are putting this surge is to make sure or to just find something to make more drivers to start accepting trips or come on board and balance this equation of supply and demand. But now, I had a time where I was working on a project and I needed to implement this. It was a ride hailing application, and we needed people we needed to be able to have such implemented so that if we have less drivers than the number of people requesting for trip, the surge would kick in. If we at a peak time, for example, maybe rush hour, like early in the morning where people are going to work, and evening when they are coming back from work, and then during the midnight, we wanted to implement surge, but I couldn't find any material that would help me. I searched and searched a lot, but I couldn't find anything on it. So this is basically what I was able to come up with modifications for this particular video. I hope that if you ever need to implement this, this would serve as a base point for you to start to build out your algorithm. But however, for those who still might not understand this, if you have used both Uber before, you will see that there is a point when you see that the pricing for a particular destination increases because there is so many people making demands, and then you wonder, oh, why did the price increase? Some people will decline, some would continue because they need to get to their location. So today I'm going to show you how I was able to achieve this for mine. Yeah, basically that's it. So without wasting your time, let's get straight to business. Now, in order to proceed, how exactly are we going to implement search? So, first of all, we need to look at the number of drivers and the number of riders that are in the system, because that would determine if we would apply surge or not. If the number of drivers in the system is more than people requesting, there is pointless to apply surge. But if the reverse is the case, that means we have more people requesting for a ride than available drivers. Then yes, we need to check that in place. So first of all, let me add a comment above that would signify what will be what is this? What we're doing. So we say we calculate want to calculate um surge pricing. Let's say based on the number of drivers and riders. So that is what we want to do. Then let me add another one. So we are also going to say that for this particular function, we would accept parameters. So let's say we are accepting the parameter, we would accept the number of okay, I think I'm using Copilot, so doing this auto complete for me. We are having the number of drivers, which is going to be a number which we just call num drivers. I can change that to number of drivers, maybe to make it better. Number of drivers. Then we'll have another one, number of riders, here. Then what are we going to return? We are return a number. We are going to return a number, which is actually the number that you are going to use to multiply whatever you have as the source, as the value. So let's say this, whatever we're writing here, let's say it gives you 1, and the price for that trip is, let's say, 1500. So that is going to be 1 times 1500, which is basically 1500. But if it was to be 2, for instance, then it's going to be 2 multiplied by 1500, which is going to give you 3000. So yeah, we are going to use this here to basically calculate that. So we'll declare a function, basically a function here. For now, I'll stop like this. And then we are going to accept parameters, number of drivers and number of riders, which is basically what we have here. Number of drivers, number of riders in the system. Now, this is just a simple function, but then you have to tell when you want to use this in your application, you just have to pass the number of drivers and number of riders. So what do we do with this particular thing that we have here? Now, first of all, we want to make sure that we define our surge pricing parameter. So I'm going to say surge pricing parameters. So we have some parameters that we'll be looking at. I think I might have to turn off this copilot because it's doing too much. So the first one for me is going to be the base. So I'm going to call it const surge base. So, and it's going to be 1. So what is that? Surge base. Oh, so I need to remove the comment. Surge base simply means the this is the minimum we can go. So this is the basic. This is the barest. So the lowest that a surge can be is 1. And why is that 1? Because if it is 1, it simply means that is the exact value. So if we have 1500 and we say 1500 times 1, it's still 1500. So that is that for this base that we have here. Now we have another one that we are going to store, which I'm going to call surge peak hour. Now this is basically at the time where there is peak hours, maybe we have I'm going to say 1.8. Maybe we have, when there is so many people requesting and we have imbalance number of driver against rider. So we have so many riders, people requesting for trip against little drivers in the system that is available to attend to this request. So we are going to say this is the peak hours. So we'll be using 1.8 to multiply. Then I'm going to also have const call it surge late hours. This one will be for when late night, let me just call it late night, and I would use 2. So if it is in the night, you are late night, especially you want to request for a trip maybe around midnight coming down, then it has a higher its surge is high because the driver is taking a risk, you know, to come pick you up. He's taking a risk. So all these things, even though we are not done, they have meanings and they have reasons why we have them. For imbalance, we have greater number of riders against drivers. Here we have you requesting at an odd hour. I'm also going to have another one. I'm going to call it surge event multiplier. Surge event is asking for rush hour. It can be the same thing as what is it called? As peak hours. It's also the same thing like rush hour. So I'm going to call this one. This one is going to be 2.5. 2.5. So when there might be an event. It could be rain. There's so many that we can add here. There's so many factors we can put in here, but I'm not going to do everything. And also, we should keep in mind that this does not mean that this is how it is for Uber or for Bolt or for other riding application. This is just what I was able to come up with. They might have other things they will factor in that I wouldn't factor in right now. All right. So besides that, I would have my threshold, const surge threshold. So what is the threshold? The threshold for me is going to be 0.8. Threshold is at what point in the system do I apply surge? So this 0.8 here is basically 80%. So if 80% of the driver in my systems are occupied, 80% are of my, okay, let me write as a comment. 80% of drivers are occupied. I'll put it as a comment. If 80% of them are occupied, that means I have about 20% remaining. I want surge to kick in because my drivers they are about to I'm getting exhausted, or the system is getting exhausted. It's already at a capacity where it needs to kick in surge to probably reduce the people, because some people are going to decline when they see a surge. They will decline, you know. So I want them to probably decline, or if you want to continue, that yes, I really want to get to this place, whatever. But this is my threshold. This is my threshold. Once you get to 0.8, which is basically 80% of the entire drivers in the system, then I want this to come in. Okay, so finally I have my surge elasticity. Elasticity. So this is basically going to elasticity. I can't spell it, which is going to be, for me, it's going to be 0.5. 0.5, I mean to say. Damn it. All right. So this is going to be an influence for, why do I have this here? Okay, I'm removing it. All right, 50% elasticity you see here. Okay, I need to put const. And what does this simply mean? This simply means that I want this to be a factor influencing whatever value that I'm going to get. So 50% increase for every 20% unmet demand. So that is what this my elasticity is going to do. So basically, I've been able to explain through all this that I have here. My base, which is basically the beginning, is just one. My peak hours, late night, event, threshold, and then search elasticity. All right, so moving down, now that we have all these things in place, we can start working on this algo. So let's begin the calculation. Now let's get the number of active drivers. So say const active drivers. How are we going to, let me make it drivers. How are we going to get these active drivers? We are going to say mat dot max. So we are going to say the number of drivers that we have in the system. I'm just going to say number to make sure that it's converted to number. Sorry, what did I do? Let me close this. And I don't know. Number and the number of drivers minus number, the number of riders, and 0. So what this is doing is we are saying subtract the total number of drivers in the system from the total number of riders in the system, and then give us which one is greater. So if this is greater than 0, then this will be the number of active driver. If this becomes negative, so we have like -1 down to whatever, then 0 is greater than negative, so it's going to be 0. So have the number of active driver as 0. Now, with that in place, we start with our search multiplier. So we say const, I'm going to use let because I believe this will be changing. Search multiplier is equals to base search. So what are we going to use to multiply whatever value we have? We set it in the beginning to base, which is basically 1 here. So we are saying that it is the first one that we are using. But then we now need to start moving down. Now, let's also store a temporary value for the multiplier. So let's say let, I'm going to say underscore temporary surge multiplier. So I already have one already. I'm going to set this one to 0. This is the surge multiplier that I'll be using, but this is a temporary one. You will see why I have this as we proceed. So this is set to 0. All right. So with this now, we would proceed to create what I would call our utilization ratio. So we're going to say const utilization ratio. I'm going to tell you what this means. So utilization ratio is simply the ratio of riders in the system against the active drivers. Remember that these active drivers are drivers in the system that is left after removing, subtracting from the number of drivers in the system against the number of riders in requesting, against the number of people requesting. So let's say we have, for example, we have 10 drivers and we have 20 riders making a request. So we are going to say 10 minus 20, which is going to give us, minus 10. And minus 10 is less than 0. So this is going to be basically be 0. So we don't have any driver in the system. So down here, we now see that the utilization ratio is going to be number of riders in the system divided by active drivers, which is basically after subtracting the number of riders in the system from number of driver, we get the max value between that and 0. Whatever is remaining is this guy here. We need to check that this value is actually correct. We don't want to get something like infinity or negative infinity. We want actual integers or actual numbers. Even though infinity, in the sense, is a number in the sense that, oh, countless, just keep counting, whatever. But we don't want that. So we're going to say if not is infinite. That means it is not number. We don't have this is not like the number we are looking for. I'm going to check this out. I don't know why this guy keep popping up. We are going to say that utilization ratio is equal to 0 if it is not, because this can become the answer can become infinity like this, and we won't be able to continue the operation with this. So we need to check to make sure that we don't have such infinite or negative infinite. We don't want that. So we have to check. So if we get this value, we just set it back to 0. And I need to obviously change this to let again. Well, so that is that on this one. So we let me remove this guy. All right, so we are checking to make sure that we don't have such value. So if we get it, we set this guy back to 0. If we don't get it, we know that the value here is actual integer like 0, 1, 2, whatever that it might be, or 0 point something. All right, so what do we do next? We are going to check, let me add a comment, to check that the, what is it called? The utilization ratio is, if it is, let me just say, check if the utilization ratio is above the surge threshold. So if the ratio of riders against the number of drivers remaining in the system is above the threshold, which is what? 0.8, which is 80% of the people in the system, then what do we do? So that's what I want to check now. So for me, I'm going to say if utilization ratio is greater than surge threshold. So if the number of if the number of if the ratio of riders in the system to the active driver is greater than the surge threshold, that means we have passed that 80% mark. We have passed that 80% mark, and we need to kick in surge immediately. So what do we do? Now we are going to calculate. We are going to use this value here now to get this temporary surge multiplier. We are going to say this is going to be, we are now saying mat.log, we are taking natural logarithm, mat.log of utilization ratio minus the surge threshold plus 1. That is that. Then multiplied by the surge elasticity. So I'm sorry. So this is the point. Let me reduce this. Where we, oh my God, this is too small. Yeah. So this is the point where we then use the surge elasticity. So what does this calculation here? What is it doing? So we are taking the natural logarithm of utilization ratio. We are subtracting it from the surge ratio. Since it is greater, so we are going to get a value back. This plus 1 here is to make sure that the value we get back is going to be a positive number. That is why we have this plus 1. It is going to make sure we have a positive number. So whatever it is, but we know that this utilization ratio is greater than the surge threshold, which means that our surge should kick in because the number of riders in the system is greater than the number of drivers in the system, or it has exceeded the 80% mark. If you go back to the top, we said the threshold is 0.8, which is 80% of drivers in the system being occupied. So once it gets to this point, that means they're already occupied. And then we take the natural logarithm, we get it, then we multiply by the surge elasticity, which is going to influence the value that we get back. So why are we using a log here? Why are we not doing a linear calculation or maybe exponential? Well, the logs, using logarithm here would help us to not get a value that would scare our users in the case of linear value, as it just increases, exponential. We don't want to have a spike. We want to actually have this value, the what is it called? The surge increase not so much. You don't want it to just balloon up immediately. So logarithm here helps in this case to avoid such cases or such case. All right, so we get this value which we store here in this term surge multiplier. And what else do we do to this? We then set it to be the surge multiplier. So when I say surge multiplier is now times. We are times equal to term surge multiplier. So whatever it was here, and then we then add this to it. So that is that now. All right, so this is basically for what? For when the when we pass our threshold, which is 80%, 0.8. But what if we don't pass that? What else are the conditions that we can check for? Now let's do, let me call it special case, special event or special case. Yeah, just use that. We would check. Let's get the hour of the day first of all. Let's say const r. Let's get hour of the day. We say new date dot get hours. All right. So we want to apply surge based on the hour of the day. So in rush hour, like in the morning when people are going to work, we want to apply that. So we're going to say if r, I need to make this go away. If r is greater or equal to 7, that is like 7 a.m., and we're just checking R is less than 10. So if it is greater or equal to 10 and is less than 10, or so I'm going to check again. Well, let me wrap this in curly brace like this, so I can do that. Or I'll need to wrap it again. Her is what are we checking this time around? We are going to say is greater or equal to 16, which is 4 p.m. and R is less than 19, which is basically 6 p.m. What do we want to do? So we're going to say that the surge multiplier is going to be, let's say surge multiplier is going to be multiply times equal to, we now say max. Max. So we are taking the maximum of these two values. Again, surge peak hours and temp surge multiplier. So what are we doing here? Let me come again. We're saying we are getting the hour of the day, and we're saying if it is 7, which is 7 a.m., if it is greater or equal to 7, and then if it is less than 10, which is from 7 to 9 a.m., or from 4 to 7 p.m., that is 16 to 19, which is 7, less than 7, which is 6 actually. What are we doing? Then we are saying that the surge multiplier, which is whatever value we are going to use to multiply what we have, is going to be max, the bigger one between surge peak hours multiplier and temp surge multiplier. So this guy here that we're going to have from here, depending on the threshold and the utilization ratio, against this guy here, which is 1.8. So depending on the value, which one is bigger, we will use that as our surge multiplier. Now, we want to also do the same thing for late hour, but I'm going to just copy this and paste it, and then change this to be late hour. We are going to say from 23, which is 11 p.m., to if it is less than 5, which is 5 a.m., and I will just take this guy away. So from 11 p.m. to 5 a.m., then we want to say this one around is going to be surge late hour multiplier. Surge late late night multiplier. So basically the same thing here. We're just looking at these two, which one is bigger, and we are going to pick that out. Now, finally, we still have one more condition to check. I might have to add comments to this. We have one more condition to check. If the number of driver in the system is greater than the number of riders, I'm sorry, riders, not drivers. That means that we don't even need to apply a search, do we? Oh, sorry, this should be number of riders against number of driver, not the other way around. If the number of riders that is requesting for a ride is greater than number of drivers, obviously this one is easy. We'll say that the surge multiplier is times equal to, we're also taking max, and this time around we are saying surge event multiplier against the term surge multiplier. So what does this mean for us is that this event, surge event multiplier here, which is 2.5, basically when we have more riders in the system against drivers. So we say it should be 2.5. But we want to make sure that when we look at our threshold, which is how many are we already using 80% of our driver? If yes, then we'll get a value from using this particular operation here, our natural logarithm, and then we are comparing to this one here. We are comparing to make sure that this value and this value, which one is greater? So whichever is greater, we pick it and say that is our surge multiplier. The same thing we are doing for all these guys here. So with this now, we can finally return our surge multiplier to whoever is calling this function. So let me just quickly add comment here. Morning and evening rush hours. I think I will just use whatever late night, whatever Copilot is giving. Special event. Is it special event? Well, this is just basically when, let me just write it. More riders in the system. When we have more riders in the system than drivers. So these are the conditions that these guys are checking for. So if you look at this whole thing here, I'm going to run them for you to see how it works. But this is basically how we are able to arrive at these things, these calculations, and we are able to implement such for this system. Maybe whatever you want to use it for. Now there could be more. Obviously, you can add more, but I'll come back to it. Let's at least run this and see what is going to happen. So all right. So let me call the function below. I'm going to run it using the node console. dot log surge, and I'm going to say we have number of drivers. Is it number of drivers? Which one is first? Yes, we have 100 drivers and 1,000 riders. So I'm going to sorry, let me pull up this guy. I'll put it this way and then pull up this guy, put it this way. All right, so if you look at this place, let's see if we can log some of these things that we have. So let's log the utilization ratio 1 at the top here before we check for if it is finite or not, and let's also log in after we check. Then let's see if we can log this guy. So we say console the log term surge multiplier. Now, if you want them to appear, so I want it to be that when it appears in the console, it's going to appear like this. It's going to say, let me copy this guy out. It's going to appear like maybe this is 9, it's going to say 9. So I just have to wrap it in curly brace like this and pass it as an object. So if you want more, you can just say D and then say D. If you want to pass pass an object to the console. All right, so I'm going to take this out because I don't need that. So and then I'll try running it. So look, we're watching out for this console here the first time, and then this console here, and then yeah, let's run it and see what we get. So if I run node index, this is index.js, index.js, and it says utilization ratio. The first time it is infinity. That is this guy here, line 30 is infinity, and obviously where the second line is this one that it is now 0 because we are checking to make sure if it is a finite number, which is not, and we have it converted back to 0. So we have 0. But then if you look at this line 39, we said, is this greater than the threshold? It is not, because the threshold is 0.8, which is 80%, and it is not. So this line of the code never gets to run. And then it goes, are we in this time? It checks, oh, we are. For me, I'm not actually. I am not, so this would not run. This is about what is the time? This is 12:17 a.m., which is 00:17 for some of you guys. So I should be around this side. I will be around this side. But then it checks. I have. Oh, I think I changed the value. This is 10 guys and 20. Anyways, it's still the same thing with 100 and 1,000. So we get to this line and we check. We say, are we in 23, which is 11 p.m. to 4 a.m. And for me, I am, because if you look at my time here, you will see that I am. But then we now check search late night multiplier. Let me open this up fully. We now say, is this mad or max? Is this and this, which one is greater between the two of them? And obviously this is 0 because this line of code never ran. Remember, the utilization ratio is 0, so this code never ran. Yeah, so this is going to be what is there. So what is that? That is about 2, which is 2. Sorry, late night multiplier. So this is late night, and you are trying to order Uber. So it is 2. But then at this last point here, it checks. Is the number of riders greater than the number of drivers? And obviously it is yes, because we have 10 drivers and 20 riders. So this now checks. And then at this point, it moves this to become surge event multiplier, which is now 2.5. So the final answer is going to be 2.5 because even though this is correct, but this runs after this has been run, which simply means that this would be what we would have. So if we were to comment this out, we would have 2 as a result. So let me save that, take that away and rerun it. And we should expect 2 here. So let's do it. And we see 1. So why do we see 1? Here, I was expecting 2. Okay, but if I look at the condition here, I can see that we are setting this guy and we are saying that it must be greater or equals to 23, which is 11, and it also must be less than 5. So this condition, both of them need to be true for this guy to run. But that is not what we want to do. We want to say or. So it can either be greater or equal to 23, which is 12, which is 20, which is 0, 0. Now we don't have 24. That is 0, 0. So this is true here, and it is also less than this. So since this one is true, it should be or. So we don't need both of them to be truthy like we have here. For here, it needs to be greater or equal to 7 and also needs to be less than 10. For here, it needs to be greater or equal to 23 or it must be less than 5. So let's run this and see what we get. What is the problem? Let me save and let me run it and see what we get. So I'm expecting to see 2. If I don't see 2, something is wrong. So let's go. Yeah, now we have 2. Now we have 2 here. Okay, so that means that it ran successfully. We now have that going on successfully. All right then. What else should we do at this point? Let's try something else. Let's make the driver higher than the rider. So we have 100 riders and we have 100 drivers and 20 riders. So I'm expecting this to be 1 because we have enough drivers, so it should be 1. So I'm going to run it and boom. Oh, wait. Let me put this one back. Let me put this back first of all. I'm pulling this. Oh, sorry. Let me put this guy back. Since we have already tested that, I want to run it again. I want to see the answer. And it still says 2. So what is the problem? What is the problem? Why do we have 2? So if we look at the utilization ratio, it is 0.25, which simply means that it is less than 0.8. So this line of code doesn't get run. But then what happens? It checks this hour here, and yes, this is what is running. So it's checking, and it say, oh, this is late night. This person is making this order late night. So what happens? Yeah, it returns 2. Let me pull this up, which is salt late night multiply, which is 2 here. This temp is going to be 0 because those line of code never ran to change the value. It's still 0 here. So what is now doing is that it's checking to see that, oh, this is late night. And like I said, I'll show my time again. It is late night here. This is Sunday, 26th of November, 2022. All right. Early morning hour. So I'm ordering this late night and it's applying that. So late night, I'm getting 2. So even though we have a lot of drivers in the system and just 20 people making this right, it still says that the surge is 2 because this is late night. The same thing would apply in early morning rush hour, the same thing, and evening, the same thing would apply. All right, so this works fine. Now I can't test this because I am not in early morning, so I can't test that, but this shows that this works. So that is that. Okay, this line never ran because the number of rider is less than the number of drivers, so it never ran. So what if, let me turn this to 200, that means it will be 2.5. So let's see. So this, when I run this, boom, it actually says 5. Wow, what is it? How did he get 5 then? Let's look at this and see how did he get 5. So we have 100 drivers and 200 riders. So 100 driver, let's scroll up, sorry. What if we come to the first point here, 100 drivers minus 200, that would be minus 100. And then this will be 0. So utilization ratio would be 0. And we actually have, where is it? Oh my God, where is it again? So we have the maximum between a minus 100 and 0, which I am expecting it to be 0 because max is 0. So if I say note, just give me a minute, and I say max between negative 100 and 0, which one is the maximum? So it's supposed to be 0. Why did it say infinity here? Why does it say infinity? I cannot say right now. I can't say because I'm expecting 0. But here, down here, it checks and it says, oh, okay. I see the problem. So what was logged is this line here, not this place. So this place is supposed to be 0. So what says infinity is this guy. Don't mind me. It's a mistake. I started to mistake active drivers for utilization ratio. So obviously, number of driver, which is 200 divided by 0. So there's nothing remaining, 0. And it gives us, oh my God, it gives us infinity. So if I say 200 divided by 0, it gives me infinity. And that is what we have here. So my head is messed up right now. All right then, so let's proceed. I want to see how we arrive at 5 because I'm surprised. My prediction didn't work. I predicted 2.5, but that was not what we got. All right, so we say, let me stretch this a bit. So if you scroll down now, So this is 0, and this line never even runs because it is not up to our threshold. So now let's say we get to the hour and we say um, obviously this hour wouldn't run because this condition is not going to be true, but this condition is now true. And then this is surge multiplier. I want to see what the surge multiplier is at this point because I believe it is the these times whatever is here that gave us 5. So I'm going to say console.log surge multiplier. So I'm going to see what it is at this point. Then at this point, I want to see what this value is that was multiplied to get that 5. So I'm going to say console, oh my god, console.log this, oh damn it. I need to give it a name. Let me call it max. Let me just call it max. Put it this way. So that means the result of this multiplied by this would be 5. Let's find out. So I'm going to exit this guy. How do we exit again? I think 2 times. Yeah. And I'll run it. 1, 2, go. And yes, I see. So I have that the surge multiplier, which is this line here, gives me 2. And of course, it should give me 2 because this is late night and this person is making this request late night. So it gives me 2. And then this guy here gives me 2.5, right? It gives me 2.5, which is here. So this is already 2, and then we now have 2.5. So I want to find out something. Let me say node. I'm going to say 2.5 times 2. That gives us what? 5. So, and that is how we have our surge multiplier as 5. So if let me exit and let me run it again. Oh damn it. Node index. Yes. Okay. So that is to say that if we have 100 drivers in the system and 200 riders making requests, and they all do this request during this late night, the surge would be high. It is so high, you can see that they are paying a lot. The surge, the money they are paying will be multiplied by 5. So let me run node again. Let's assume the money was supposed to be 1200. Then 1200 times 5. They are paying 6,000. Can you imagine? They are paying 6,000 because of the surge factor. So they are paying for number one, they are ordering at late night, and also there is not enough drivers to go round. So this will bring the whole thing to a conclusion, but keep in mind that you can expand this. You can check for weather condition, is there rain, or is there traffic, and also add more conditions to your search, improve the algorithm for your search. But I'm going to stop here. I hope that this was able to clear it and serve as a base for you to further for further expansion of your own algorithm if you ever need to do this or if you just want to know how this works. All right. So guys, subscribe to the channel, drop your comment, tell me what you think about the video, what you think I can improve, and what you would like to see. I will see you in the next one.